Alright, 3G is looking at transformations of power functions. So we're looking at our quadratics, our cubes, our quartics, powers of 5s, etc. Okay, so we're just looking at those power functions. So if we look at this in particular, we've previously seen this format before. A is our dilation away from the x-axis, H is a horizontal shift, and K is the vertical shift. So this is our previous look at it. Remember that if our dilation factor is less than 0, then it's a negative and there's a reflection. These points here are pretty important. These are just highlighting what we have. So if you have a squared value, you have a turning point. If you have a cubed, it's a point of inflection. If you had a power of 4, then we're looking at turning point again. So even powers, turning points, odd powers, points of inflections. Alright, example 1, which is sketch the graph of y equals x minus 2 cubed plus 1. First thing to note is that that's a cube, which means that we have a point of inflection. That point of inflection is given by reading off from here. So if you go x minus 2 equals 0, solve for x equals 2, so that becomes positive, and the plus 1 shifts us up 1. So 2, 1 is our point of inflection. There's no reflections or anything like that, but let's find some intercepts. So y equals 0, rearranging to find what x equals, we find that x will equal 1. So I can plot some points. I've used some, I suppose, intuition here. I could substitute in x equals 3, for instance, and find that it equals 2. However, I don't really need to. I know my point of inflection is at 2, 1, okay? I know I have a point at 1, 0. Because there's this symmetry involved in a cubic, what I can do is say that if I've gone across 1 and up 1, then I can do the same thing across 1 and up 1. This is not linear. I'm not going to draw a linear graph here, but there is a relationship between the points. It's almost a rotational symmetry. So I can, I suppose, find some more information. So a y-intercept, make x equal to 0, solve for y, and I get out -7, so there's another point. Now I'm going to draw this. It's got that stationary point of inflection that's at 2, 1, so make sure it flattens out in the middle here. And I'm going to label some points, so I've got some scale, making sure that one of my labels is this point of inflection. That's a key point, so you will need that, and you'll need your intercepts as well, as that's another key point, or another 2 key points. Alright, example 2, same sort of thing. We are looking at a cubic again, with a point of inflection, in this case at 1, 2. And this one has also got a reflection, so note that negative out the front. Finding my y-intercept, so x equals 0, I get out 3. And then just finding some extra points. This is literally just a substitution. Kind of note what I'm doing here. I had a point at 0, I have a point at 1. Although I'm doing a calculation, you actually don't really need to. You could use that rotational symmetry and find the next point, but I'm actually doing a substitution, and that's going to give me out 1. Alright, so there's my 3 points, just like I had before. So 1, 2, 3, where the middle point is my point of inflection, so it's going to flatten out here. That's enough to graph it. I could get more points if you wanted more shape. For instance, you could substitute in 3. 3 minus 2 is 2, 2 cubed is 8. So -8 plus 2 is -6. So there's actually another point down here. It's fine to do that. It's up to you. But you won't be penalized for not doing it. You do again need some scale. So 0, 3, 1, 2. Sorry, 1, 2, and 2, 1. But you're not going to, well, you don't require this 2, 1. The 1, 2 is the important one, your point of inflection. Alright, example 2. The graph of the function y equals a bracket x minus h, close the bracket to the power of 3, plus k, has a point of 0 gradient at 1, 1, and passes through the point 0, 4. We're asked to find the values of a, h, and k. Note that this function has a cube, or it is a cube, so the 0 gradient at 1, 1 is actually referring to a point of inflection. That point of inflection will give us 2 of our unknowns straight away. So the point of inflection as we've previously seen, is hk. So substituting in 1, 1 as that point, we can say that h is 1 and k is 1. So we've actually found 2 of those pieces of information given 1 point. If we substitute that into our equation that we were given, so y equals a bracket x minus 1, all cubed plus 1. So that's our function as it stands now, where we have one unknown. So our one unknown is the a value. We also have one more piece of information we haven't used. So we haven't used 0, 4, which means that I suppose is the piece of information we're going to focus on now. So substituting in 0 for x and 4 for y, we can find out what a equals. So 4 is equal to a times negative 1 plus 1. So this part here, negative 1 cubed, this is negative 1. And I can minus 1 from both sides and then divide by negative 1. So I now know a is equal to negative 3. And as we're after the values of a, h, and k, I'm actually just going to rewrite this so I can box it neatly. A equals negative 3, h equals 1, and k equals 1. Red box it, and that question's now complete.